All right, so this circuit is the one we are using for the power factor correction for that code I just showed you. So now, or should I say for that code we worked on? So now, if you look at this, there are certain things that you should maybe understand quickly before I could just run the simulation. So, um, if you look at the way this circuit is wired, the way the wires have run, like you see that, you're going to understand really this well when I run the simulation at half the full speed, so that you understand what I mean, that some of the components here, like these wires, are very cardinal and key when you're designing a complex system on how they run and how you join them and all that stuff. So your simulation might not run because of certain things like this. And if you see here, um, whenever you're designing a simulation or a project in Proteus, um, always pick components which are labeled or which are named SPICE model, or sometimes called animated model. But in most cases, or to be on the safer side, using SPICE model labeled components makes it easier for your simulations, because only the SPICE model labeled components are able to do the simulation. Not everything in Proteus is meant for simulation. Some of them are just there for schematic capture, right? So if I double click here, you see that this is not, you see the label and everything is not a model part, it's just for schematic. All right, there are certain times when you use a program like Proteus, just you compile your model without simulating it. If it compiles by using what we call the netlist, then you understand that even your hardware is going to work because your netlist compiled. That's another reason, that's another use that we use Proteus for. But the most popular use in education circles is the simulation, where you want to simulate and see, and also in business circles, you want to simulate and convince your investor that it's working. But in manufacturing purposes, you can just use netlist. If it compiles, the assumption is that even when the hardware is going to work. Okay, so here, now we are using an Arduino Uno and the screen and everything, but now my concentration is on this relay. So when you look at this relay, you see that its nominal coil voltage, in order for you to excite the coil, you need about 230 volts, all right? And it has a very low coil resistance, which is about 0.1, okay? So if you look at, if I take you back, let me just close this. If you come here, if you look at this, one, it's not a SPICE model. Two, if you see the voltage that you have provided here, that's able to excite from your driver here, from your relay driver, you see that you have only provided 5 volts. But for this coil to be excited, you need about 240 volts. So this makes this not to work. Even if you, when you send the command here by means of a current signal, such that asking for any of these coils to be excited so that you can engage this capacitor so that you start your power factor correction, it turns out that that cannot be done because the voltage demand of your coil is higher. So having that said, let me just run the simulation just a bit so that show you. Okay, so this will be a point of concentration. All right, so if I do run my simulation, you see what's going to happen. Okay, so I won't run it in full speed. I'll run it in half the full speed. All right, so if I run it in half the full speed, you see that nothing shows there. All right, nothing shows at all. But now for you to understand what I've been explaining, I'm going to run it now in 3/4 of the full speed, then I'll show you.